Hello, everybody. Happy New Year, everyone. I hope 2024 is off and an incredible start for all of you. May this year be filled with exciting new projects, groundbreaking innovations, and countless opportunities to learn and grow. I'm absolutely thrilled to be joining you all virtually for .NET Conference 2024 Cameroon. Today, we're going to dive into deploying the Aspire application and the Kubernetes using Azure DevOps pipelines and explore how we can leverage the power of .NET to build amazing cloud-native applications. During the session, we will take a brief look at Aspire applications, then we will have a look at deploying applications to Kubernetes, and finally, we will talk about deploying to Kubernetes automatically using Azure DevOps pipelines. My name is Wahid Farahmandian, lead software engineering from Iran, C# Corner MVP, international speaker, and book author. So let's start the session and see how we can deploy our Aspire applications to Kubernetes. In order to deploy our applications to the Kubernetes, our Aspire applications to Kubernetes, we need to have an introduction about Aspire, what is Aspire, how it can help us, and many other notes. Let's take a look at here, Aspire overview. You can refer to the Microsoft documents. Aspire is a set of powerful tools, templates, and packages for building observable production-ready applications. The main point here is that Aspire is delivered through a collection of NuGet packages, which we will explore them in the second part of our session. It's used to build the cloud-native applications, and of course, cloud-native and of course, distributed applications. A distributed application is one that uses computational resources across multiple nodes, such as container running on different hosts. So, in this session, we will talk about the different kind of resources we can have in our Aspire application and how we can make a bridge between them and communicate and make the data to be communicated between these nodes. And we will talk a little about the network boundaries to be configured in order to our Aspire application to work correctly. As I told you, in order to work with Aspire application, you will need to have a .NET 8 or .NET 9 installed on your computer. You will need an OCI compliant container runtime, such as Docker Desktop or Podman, or any other OCI compliant container. In this session, we're going to use Docker Desktop, and also you will need an ID such as Visual Studio 2022 or Visual Studio Code or JetBrains Rider or any other ID. We will use the Visual Studio 2022 and Visual Studio Code in this session. In order to create an Aspire application, it's very straightforward. Using Visual Studio, you can search the Aspire at the top of the screen and select the Aspire starter application. This starter application will load with the default projects, such as the API servers projects, which acts as our backend projects. In fact, the API service project will provide the data for us. We will have the app host project, which is our orchestrator project. The main point of .NET Aspire is this project, and we will work directly with this project. The third project, which is loaded as service default, is a shared project containing the shared configurations, which is used among the other projects. And finally, a web project, which is act as our front-end application. By default, the web application, the web projects here is built based on the Blazor. Of course, you can change these projects, add any other projects, or remove some of them. But the most important projects that you need to maintain it and you cannot remove it is the app host projects. It's a vital part of the Aspire projects. It should be placed in our solution, and of course it should be set as startup projects if you want to run our projects locally. Let's take a look at the Visual Studio after creating the Aspire application. We will have this project in our solution. Here is the API service. It's minimal API project by default. It has a weather forecast API here, which is return some randomly generated data related to the weather through us, and there's nothing special to this project. Let's take a look at the web project, which is Blazor project. It has the program CS here. The HTTP client is configured here to connect to the API service here, which is our API service project. And also it uses the output caching in order to cache the subsequent calls for our API. We have the service default here, which contains some extension methods in order to configure the service defaults, to configure the OpenTelemetry or other services. And finally, the vital parts of the project, the app host, the orchestrator part of our solution, our app host projects, any programs, yes, we have very important codes here. By default, these codes are written the template generation for us. This code says as we have a Redis as a resource here, which we are going to call it cache. It's just a name which we provide and which we put to the Redis service. Then we say that we have another service. Our service is as type of a project based on the .NET Cameroon API service. It is our API service here. Okay. And we name it API service. And also we call the orchestrator that we have another project called .NET Cameroon Web. We put web frontend label over it. This web front resource has a reference to the cache resource, and it should wait for cache resource to be stored. And after starting this resource, the web front end is able to start and become online. And also it has another reference to the API service. The references of type wait for. Totally, this means that web front end will become online whenever the cache and API service both are online. If cache service or API service, any of these projects fail to restart, then web front end also will be failed, and it will not become online and cannot start using the web front end project. So it's very important to configure these services very concisely and define the relationship between projects with very good details. Okay, we're not going to change this code here. This fine and so okay for us. In order to add another projects, we should do the mechanisms we did before. We can create new projects, define our business rules, or define our own codes in that projects. After developing that project, we need to define its rule in our orchestrator and its relations with other services in the project's graph. After creating the Asper application, we need to get some information about how we can deploy the applications to Kubernetes. Okay, let's take a look at the Microsoft documentations and see what they have for us. In order to deploy the Asper applications, we need a deployment manifest or manifest file. In fact, the manifest file contains the project's graph in JSON format. The codes which we have written here will be converted into JSON JSON presentation. Sorry, it will be converted to the JSON presentation as it will construct a project graph which shows us the relationships between projects. Okay, after creating the manifest file, we can decide whether to deploy the .NET Asper applications to Azure or deploy it to the Kubernetes. Of course, we can deploy our .NET Asper application to Azure Kubernetes service. They all are like each other, and there's no difference between deploying to Kubernetes and Azure Kubernetes services. The The deployment options for Data Aspire is on its way to be completed, and other destinations are being developed, and in the near future we might have another options for deployment. But up until today, we have two options. We can deploy our .NET Aspire application to Azure and deploy it to the Kubernetes. The important question which arises here is that can we deploy .NET Aspire application on legacy web servers such as Microsoft IIS? It's a very important question. The short answer is yes. We can deploy our .NET Aspire application on IIS. The more detailed answer may become with the answer no. We cannot deploy .NET Aspire application on IIS. So let's take a look at why we can deploy it and why we cannot deploy it. .NET Aspire application in its nature is some web applications and some class libraries. There's not anything special. The special part here is our orchestrator or app host project. If we want to deploy our .NET Aspire applications on legacy web servers such as IIS, we might need to ignore the orchestrator, and we might need to deploy the API service and our web front-end projects independently on our legacy web servers and start configuring a relation between these microservices or between these different parts of projects manually. But if we want to use the orchestrator, of course, we need a cloud infrastructure. This cloud infrastructure could be become ready by the help of the Kubernetes, by the help of Azure or any other cloud provider. So again, can we deploy our .NET Aspire application on IIS web server? The answer is yes and no. Yes, we can deploy it if we ignore the orchestration part. No, we cannot deploy it if we do not want to ignore the orchestrator part. Okay. In order to deploy to the Kubernetes, we have two options. We can use the Aspire 8 project. It's an open source project, an awesome project, awesome and very useful project, which is there to make the whole procedure of creating the Kubernetes files and to facilitate the whole deployment process for us. Of course, we can also create the Kubernetes manifest manually in order to deploy the applications directly to the Kubernetes. In order to use the Aspire to deploy to the Kubernetes in this session, we're going to use the Aspire 8 project. Aspire 8 project has a very good documentations. You can refer to it and read the different parts of the Aspire 8 projects. Generally, it comes with 4 important commands we should consider. The first command is aspire init or aspire initialize the command, which is here in the command sections, initialization section. We can read more about this aspire init command. Aspire is used to initialize the Aspire project current directory. The second command is aspire generate command. It generates the Kubernetes manifest based on the .NET Aspire application host manifest file. It's where the most important part of the deployment is Aspire generate section, because here we're going to generate the YAML files, we're going to configure our network details, and many other things are going to be happening in this command, in Aspire generate command. The third command is aspire apply. It's very similar to Kubernetes command kubectl apply command. It applies the generated Kubernetes manifest to the Kubernetes cluster. And finally, we have aspire destroy. In order to delete the resources created by the apply command, we can use aspire destroy. And in order to use the Aspire in your computer, you need to install it. You can use a .NET Tool installer or any other installation options provided by Aspire projects. If you want to install Aspire using the .NET Tool, you can use a .NET Tool install -g Aspire pre-release. -g means install Aspire globally, and pre-release says that include the pre-release versions of Aspirate. If you do not want to include the pre-release versions, you can omit it. Okay, in order to deploy the applications to Kubernetes using Aspirate, after installing the .NET tool install Aspirate, we can start using the commands aspirate init, generate, apply, and destroy. Okay, let's see what we have here in the practical section of this session. We had take a look at our projects. Okay, we do not need this Visual Studio anymore. We can close it. Okay, our source codes are here. That's my projects. It's my solution file and my app host section. I told you that the most important part and the most important part which we are going to work with it is app host section. So in order to run the Kubernetes and Aspirate commands, we need to navigate to the app host folder and start writing our commands here. Let's open the terminal, copy this. Okay, let's navigate to that project. Okay, we're in the app host project, clear it. First things we need to do is to run the aspirate init command. Let's put it here and see what's going to be happening background, which files are going to be created for us. Okay, when I write the aspirate init and click on enter, it just starts asking me some questions. For example, it starts asking me that do you want to configure a fallback value for container registry. By default, Aspirate will use the Docker IO as the container registry in order to discover and resolve and download and pulling the Docker images. Of course, in the production environments or in the serious environments, we might have our private registry, so we need to set our fallback container registry here. In this session, I have a private registry which is using the registry Docker image here. Which is using the registry Docker image here and hosting this kind of container, which is hosted on port 5000. So I need to say, yes, I need to configure the fallback container registry. Okay. Which is on localhost 500. Okay, it says that do you want to configure it? Yes, I want it. So I need to give it the my private container registry address. After that, it says that do you want to use the prefix to the container, to the image which is going to be created during this Aspirate project. What's prefix? Prefix is used to name your image. For example, here the registry.kubernetes.io is a prefix to the image etcd. We can create prefix for our own image and categorize our image based on that prefix. However, I'm not going to use the prefix. I'm just ignore it. Finally, it says that do you want to use templates? No, I don't want to use templates. Okay, aspirate init, finish. What happens background? We have some near guess here. We have aspirate.json file, which is generated for us. Let's see what's inside the aspirate JSON file. Oh, the configurations which we have set in the terminal, they all have been written here in the aspirate.json. Okay, great. Close it. The second command we're going to write is aspirate generate. Aspirate generate is, as we told, is used to generate the Kubernetes files. Okay. First, it asks about password. This password is used for secret management. You can put anything on it, but you should remember it because we're going to refer to this password in the upcoming steps. For example, let's say that, okay, my password is 12345. Retype it, okay. And we're waiting for the Aspire generate to discovering the Aspire manifest file and gathering the required information. Okay, it has discovered our projects and find out that we have 3 different services named Cache, API service, and front end. these words are the words which are obtained from program CS here. That's equal to these names which we have put on our resources. It has discovered those resources and says that, okay, which of these services are you going to deploy on the Kubernetes, or which, I should create a Kubernetes file for which of these services. We can select all components in order to create Kubernetes files for all services, or we can navigate between them and select a specific one in order to create the file for a specified service. I'm going to select the all components. Maybe you might also need to select the all components in your scenarios too. Okay, hit the space in order to select all the options and hit the enter. After that, it says that you need the dashboard and connect to the OTLP endpoint based on OpenTelemetry, which is very vital for the microservice tracing and for microservice monitoring. Of course, I need it, yes. Okay, it starts to building my Docker image. Oh, there's an error here. Oh, I have misspelled my localhost here. But no problem. Before diving to the error, let's see what was trying to handle during the Aspire generate. In the handling projects steps, it's just going to build my project, and after building the project, it tried to push my image to the localhost 500 address, and also it was tried to label my Docker image as API service and put the latest tag over it. Okay, but as the error indicates, the address here is wrong, and we need to again go to the Aspire init, or we can go to the Aspire JSON file and resolve the errors in that file. Okay, I'm going to regenerate the Aspire init command. It says that, okay, I find some configurations. Do you want to overwrite the configuration? Yes, I want to overwrite them. As you said in the background, that some files have been deleted. Okay, do you want to set a fallback? Yes. What's your fallback? It is localhost. Okay, I don't want to use the prefix and templates. Thank you. And Aspire generate. It says that Stu wants to go through the values which you have provided in the previous try, or you want to provide new values. Totally wants to provide new values. Okay, so okay, we can go with the previous values too. Okay. It again asks about the passwords. I provide password. Yeah. Okay, here's password. Again, it's going to discover the project. In handling projects, there's some problem with the localhost. Why it does not be put through? Let's see what's in Aspire in it. Does the localhost here? Okay, let's open it here. It must be localhost. It's localhost here, and the Aspire state JSON file here. Okay, we have found it. It is localhost and saved. There's okay. Again, Aspire generate. Okay, it has built the projects and also build the Docker image named API service. We can view it here. We should see the API service Docker image here. Let's refresh it. Here we should wait for moments in order to Docker image become available for us. However, it says create the API service Docker image and web front Docker image for us. There's no Docker file or components have been selected. Let's ignore this part. And and the other parts. And finally, for the Kubernetes, again, it asks me whether do you want to use a custom namespace. Custom namespace in Kubernetes is a bit like using the prefix for Docker image. It's used to categorize the Kubernetes resources. Yes, I'm going to use the custom Kubernetes namespace, or no, I don't want to use a custom namespace because I'm going to put this practical example as simple as possible. Do you want to top-level customize manifest to generate against the Kubernetes cluster? Yes, we need to customize manifest. We will discover it and see what's it. Okay, aspirate generate as finished. The final command we need to execute is aspirate apply in order to apply the generated files. Let's take a look at what the generated file. Aspirate generates, creates aspirate output folder here. Inside this folder, we have folder for each of our resources and 2 files for our orchestrator or dashboard. Open the dashboard YAML here. It's going to use the .NET Aspirate dashboard Docker image. It has some limitations under CPU and memory resources. Creates, and finally here, the network section. It's going to use the cluster IP. It's very important. When the type here is equal to cluster IP, it means that this resource will be available inside the Kubernetes clusters. It will not be visible outside the Kubernetes cluster. For the customization YAML here, it says that we have some resources inside these folders and inside this file. It's used for better organizing the files. Our web frontend folder contains deployment YAML. It says that's what's the name of this, the metadata, the name of the metadata, what's the name of the metadata, which image is going to be used. It's going to use a localhost 5000/webfront and latest tag. And the network part here is going to use the port 8443 for HTTPS traffic and 8080 for HTTP traffic. Again, the important part here is the service YAML file. As you see in the service YAML file, it says that's the type of this, the network of this resources cluster IP. What does it mean? It means that this resource will be available inside the Kubernetes cluster. Okay, what does this sentence mean? It means that when I deploy these resources on the Kubernetes, I will not be able to browse it in my browser. I will not be able to write here, for example, localhost my application port. I will not be able to browse my application here. So it's very important to change these values. We will discover is that what should be set here. We're just taking a look at now. We're just taking a look at the generated files. These files are the same for the other 2 resources. For the cache and API service, we have the same files and same structures there. So, okay. Aspirate generates the files for us. I'm going to raise the aspirate apply in order to apply these YAML and these Kubernetes files. Okay, let's run the aspirate apply. Let's click on nodes to see what's going on here. Again, it's asking me about the password. This password should be equal to the passwords we have typed in the aspirate generate command. So let's retype it here. I told you that this password is using for the secret management. You can totally ignore it, but it's better to have the password in order to encrypt the confidential information such as your conscience string and anything like that. It says that still wants to deploy the generated manifest to Kubernetes cluster, define your kubeconfig file. Of course, yes. Which Kubernetes context you are going to use? I'm going to use a Docker desktop context in order to do deployment. Okay, it says that to apply manifest to cluster cannot be null, value path 1. Okay, that sucks. This is very common error we've been faced while working with Docker Desktop and Kubernetes together. In order to solve this problem, we need to restart our Docker service. Docker Desktop service needs to be restarted, and also the Kubernetes service needs to be restarted too. So we're going to restart these services and continue to see what's going on here. But let's retry again with Aspire update applied to see whether it bypass it or we have been enforced. Okay, we've been enforced to restart the services. So let's restart services and see what's going on here. Now to restart the Docker Desktop services, we can just click on here and select the restart option here. Okay, it has stopped the Kubernetes services here and started stopping the Docker engine. Again, tries to start the Docker engine. Okay, we should wait for Kubernetes also to be starting. Okay, Kubernetes is up. Let's retry the Aspire to apply here. Okay, we have there. We need to come here to the Kubernetes section, reset Kubernetes clusters total. After resetting the Kubernetes cluster, we need to rerun the Aspire apply command. Okay, it's been executed and the Kubernetes files have been applied to the containers, and now we have our containers in Docker Desktop. Let's see this. Okay, as you see, we have our image here, and of course our containers which are running here. The important part here is the network configuration, which have been talked. For example, for our web front end as the most important part of the application, which the end user is going to use this application. Let's take a look at the network configuration for it. Is you're going to use a cluster IP. It means that the web frontend application will not be accessible outside the Kubernetes cluster. It means that the end user will be unable to access these applications. In order to make it accessible outside the Kubernetes cluster, we need to change the type from cluster IP to node port, and also change the target port to the node port. For HTTP traffic, I'm going to assign the port number 31001, and for HTTPS traffic, I'm going to assign the port 32001. Okay, after changing these values, again, we need to re-execute the Aspire apply command in order to apply this change to the Kubernetes cluster. Okay, it says that we have misspelling here. It's noded port. Okay, it's node port here. Again. Okay, the changes have been applied to the cluster. So now I can go to the localhost 31001, and here's my application. The different pages are here. My weather, which is reading data from the backend API services, which is inside the Kubernetes clusters, and my backend API services is accessible outside the Kubernetes cluster. Okay, up to here. In order to automate the whole process, we need to design a pipeline in order to execute these commands inside the pipeline. But inside the pipeline, we have not any interactive capability in order to provide values during the pipeline execution. So we need to write these commands in the non-interactive modes. In order to convert these commands to the non-interactive mode, we can refer to the Aspire documentation. It has comprehensive documentations related to writing the non-interactive commands. But for now, we can rewrite the Aspire init command like this, Aspire init, and pass the required values as different switches here. For example, pass the container registry for our fallback container registry with the switch non-interactive, which is important or required in order to make this command to work in non-interactive mode. Or for aspirate generate, we're going to say that, okay, aspirate generate work in non-interactive mode. Use the aspirate manifest file, which is located at the root. Also use the image pool policy always. Also use the container image tag, for example, 123. As you see here, our image here are going to be tagged with the latest value. Here I'm going to change that tag to the 123. Also provide the secret password here and says that's okay, include the dashboards for me too, or for aspirate apply command. Again, I've defined the password here. This password should be equal to the password defined here, and says that use the Docker desktop for the Kubernetes. Let's recheck the whole process using these commands. I can copy this command here. Okay, paste it here. It's full. Okay. As you see, it has applied the change without asking me anything. Okay, it's great. The generate command here, paste it here. Okay, it starts executing the generate command. There's okay, we have the password. Our password is 12345. Okay, without asking me anything, it starts generating the Kubernetes files. We should wait in order to image to be created. And after that, we need to run the aspirate apply command in non-interactive mode. We're just waiting for the aspirate generates to finish the job. Okay, it has been finished. And aspirate apply command. Oh, we have password here. Okay, it's applied the change without asking me anything. Okay, now that I know how to run the commands in non-interactive mode, it's very easy for me to design the continuous integration pipeline. In order to design the continuous integration pipeline, I need to run the aspirate init as a first task. Then I need to execute the aspirate generate as it's here as a second step. And a third step, I need to execute the aspirate apply command in order to deploy the aspirate application to the Kubernetes. But there is one step we have missed here. This step is for resolving the network port and network connectivity issues here. We have many options in order to change these values, but during the pipeline, I'm going to use the PowerShell task in order to replace the whole text of the service YAML with the correct version during my pipeline. That PowerShell command needs to run between the generate and apply commands in order to define the network configuration in a correct manner. Okay, let's go to the Azure DevOps. Before going to the Azure DevOps, let's remove everything. I'm going to call aspirate destroy in order to remove everything related to my Kubernetes. Okay, it's been deleted. Here in the Docker desktop, as you see, my Kubernetes pods and containers will be going to be okay, stop. And after stopping, I can remove my image here. Let's remove the image because my continuous integration pipeline should create this image for me, and I do not have any concerns related to this. Okay, remove the image. Okay, great. Everything is clear. These containers will be cleared automatically too. We have no option with here. Okay. Close it. Okay, let's go to the Azure DevOps. I have pushed my codes to the Git repository here. So my codes are available in the Git repository. And the pipeline section, I have defined the continuous integration and continuous deployment pipeline. It's, again, the simplest I tried to put the pipeline as simple as possible. Let's read what's going on the pipeline. We have name here, which is going to define the build number format for our pipeline. I'm going to use this format as the image tag value. Okay, I'm going to use the pool named default and steps. First task is the command line task. I'm going to cd.NET Cameroon app host. What does it do? Okay, this is my repositories. Executing the cd.NET Cameroon app host will cause the agent to come here. Okay, now my agent is here. I tell the agents to run the aspirate init with container registry loopback address equal to localhost 5000 in non-interactive mode. This command is this command that we have executed before, and after that execute aspirate generate. In order to execute aspirate generate, I told it to use this format as the image tag format. The build number variable value is going to be set from this line. So my image will have a tag value equal to the build number variable. Of course, in the secret password section also, I have defined a variable called password. I'm going to replace the value of that variable with the secret password here. The variable for password here is defined in the library. Here in the library, I have a variable group called .NET Cameroon. In .NET Cameroon, I've defined a variable called password and converted to secret in order to prevent it from to be shown to the other people. Okay, it's now more secure. Of course, it's more secure than these options that we had here. Okay, I have my secret password here. After executing the aspirate generate, I'm going to call the PowerShell task. I'm going to say the PowerShell task that go to the aspirate output web frontend folder. Okay, it will comes here. Okay, and then I told it that there is a file called service.yaml, read its content, and after reading the content, replace the content with this content I provided for you. Here I'm going to replace the cluster IP with node port and target port with node port, and also with my desired port numbers. After replacing the content, I'm going to save the contents in that file again. After replacing the values, the final commands I need to execute is aspirate apply. Again, I told him that go to the .NET Cameroon app host folder and execute aspirate apply in non-interactive mode. Use the password and the Docker desktop to apply the change to Kubernetes clusters. Okay, let's run the pipeline to see what's going on here. Okay, we're waiting for the pipeline to be started. As I told you, the pipeline is using the pool named default. Pool named default has an agent, which is hosted on my local computer. Okay, it's offline. I need to run the agent. I've defined an agent here. Okay, let's run it. Okay, the agent's now is up. Okay, it's online, and my pipeline can start running the job. Okay, it starts checking out the code. It means that's going to clone the code to my local computer. Going to run the cmd line command. As you see, it's run the aspirate init and aspirate generate. It's just waiting for the files to be generated. Here you can consider the container image tag, which is equal to the build number format, which we have defined. PowerShell replace the network configuration and final command line used to execute the aspirate apply command. Okay, let's get back to the Docker. We have our containers here up and running. We have also our image local plus API service with a meaningful tag, which is equal to our build number format, which consists of the year, month, day, and the number of the revision of the build pipeline, the number of the build pipeline executions count. Okay, and here in the local host 31001, we have our application counter, it's working, okay, and whether getting the data from backend services and so on. Okay, let's test our pipeline. For example, let's go to the web application here. Okay, to the component section, page, whether I want to test and see whether my new chains are going to be applied to the Kubernetes cluster or not. We can test this very simple. Let's change the weather to weather 2 here and commit the change. Okay. We need to rerun the pipeline. What I expected to see is that this weather should be changed to weather 2 after running the pipeline successfully. Okay, it has generated a new image tag called 2025 01072. The previous value was 1. Okay, the new image has been created. Network configuration replaced and aspirate apply command executed. Simply come here and refresh the page. Okay, weather change the weather too. With this change here and with this example, we have get to the end of the presentation, and during the session we have took the look at how we can deploy the .NET Aspire application to the Kubernetes user Azure DevOps. As you see, it is a very simple procedure. It's very important to understand the theories between these operations. After understanding the theories between the operations, we can easily interact with them, and we can easily combine them in our software development life cycle and in software development cycle, of course. For the end of the session, if you want to contact me, you can find me on GitHub using Vaidfarahmandian ID, or in LinkedIn using vfarahmandian, Instagram Vaidfarahmandian. You can connect me in email using farahmandian2011@gmail.com, Twitter _Jinget. You can read my blog posts in Medium at jinget.medium.com, and also read my posts in C# Corner using c.sharpcorner.com/members/Vaid-Farahmandian. I hope you enjoyed this session, as it would be practical and beneficial for you. I hope you have very lovely and very great New Year. Hope to see you very soon, everybody. Goodbye. Goodbye.